I was going to show a short video, but in the essence of time, I'll move straight into the presentation. This is an image that you might not typically expect to see at an energy conference, but I wanted to first introduce Ecocentric a little. Ecocentric won't be known to many of you. We're a Fremantle-based business that's been around for a couple of years now, but we've been heavily involved in R&D and moving our way into the market. But fundamentally, we're a business that perhaps represents a new crop of business, both big and small, that are driven by what we call conscious business principles. And fundamentally at Ecocentric, we've started a company that believes that good business can in fact be doing good at the same time. They need not be different things. And certainly a lot of feedback that we've had from the market embraces those ideals and has been rewarding us in terms of being brave and committed to who it is that we are. And an image like this might not resonate for everyone, but certainly for me, I started life out as a marine biologist and gravitated my way into energy and, one step to another. But fundamentally, what we see in nature is not only beauty, but we see incredible design, designs that have emerged over some 4.5 billion years of R&D effectively. And so at Ecocentric, as a developer of technology, we very much want to work in harmony with nature and make sure that our technologies actually support nature and see us coexist in a better, more sustainable world. The first expression of this philosophy for us is a product we call Numen. Numen's a Latin word. It means the spirit or energy that resides within a place or an object. And fundamentally, Numen is a system of bespoke hardware that we've designed that acquires incredibly high frequency, accurate data. We use a complex mesh communication network to ensure that that data can make it to our cloud-based platform, where some pretty fancy analytics go on ultimately before being visualised on our front ends for customers. Fundamentally, what we talk about is energy enlightenment, and some of it draws on from, if you like, some of the failings of the market to date. And my experience is in commercialising Numen and developing Numen is what I use today in terms of making some observations about where we are, but also where we can go. And there's a few things to point out, and thankfully they're a little consistent with the first speaker. And that's that actually many of us have a goal to do something about energy. So that's a real positive thing. But fundamentally, what we then find out is that actually most of us don't achieve those results. And when you look beneath the surface to try and understand why it is that we don't achieve things, it's quite now well understood that access to quality data is a key part of that equation. Either if it's present, you can achieve reasonable results, or if it's absent, you tend to fail. And so that's pretty well understood now, and the market's been responding to that challenge over a period of time and revealing data to end users in multiple forms, and we've heard some examples of that already. But what's key and what's not always understood is this part, the analysis of that data. And fundamentally, someone has to do this piece. If there's going to be an investment in energy efficiency or an activity taken to reduce consumption in some way, shape or form, someone's got to analyse that data. If you leave it to the end user, that's one approach. It's a cheap approach, but leaves it to chance very much. If you lead it to a service provider, then it could be too limiting in terms of what it does. There may be intermediaries who want to do it, but fundamentally, someone needs to do this if there's going to be outcomes. And so what's started to come into the vernacular now is machine learning, not just in this sector, but certainly in this sector. And people are playing around with it. People are banding it around. People are using it, and not always understanding what it is, in fact, they're talking about, but using it increasingly as being a way in which they think that we can promote better outcomes and, in fact, deliver those outcomes more cheaply so that end users, whether they be in business, industry or households, ultimately reveal good insights in order to be able to make some change. And so I was searching for a definition of what it is that we could look at, and I found an essay by this fellow, Bernard Marr, online, and I found its simplicity in terms of machine learning attractive. Fundamentally, we really just want to be able to give machines access to data and let them learn for themselves. Now that certainly is a very effective and efficient way of achieving outcomes without manual intervention, and if we can achieve those sorts of things, then we can augment the systems that we've got. We can use the data that we have in order to provide quite bespoke and meaningful outcomes. The other thing I like about the simplicity of this is that if you think about technologies that have really taken off, they're simple. They might not be simple in their design or the technology that underpins them, but they're simple in their application, which makes it very easy for lots of us to use. This is the sort of challenge that we need to respond to in terms of making energy data analytics available to the masses. And if you're going to do that, you need some grunt. And for us, no better grunt is there than the CSIRO, including its Data 61 team. This is a team under the Energy Flagship based out of Newcastle, but also, as I mentioned, we work closely with the Data 61 team. And I mention these guys because they've been an amazing partner for us. They've brought technology to the table, they've tested our technology, and they've made us fit for market, but also given us a significant competitive edge as a small business. I also mention them because there's one very particular type of technology that they've developed that we're now commercialising that all relates to identity and the way in which you use machine learning in order to understand identity. So let me first use a simple analogy. So here we have an image, clearly a human image, but what more can you say about it? You don't particularly know whether it's male or female, you might have a view. You don't know what its ethnicity is. You don't know what its age is. You just know that it's a human, and how useful to you is that? It's not until you actually start to apply some details and add some features that you start to see patterns and things that actually allow us as human beings to identify this as an individual. Hair colour, length, eye colour, shading in the skin, etc., are all part of the features that make this woman unique. They're all part of the features that allow us to very quickly identify her as different to someone else. And this technique is what we're now using to look at electrical data sets. So let's take that analogy and apply it to electricity. So a very simple sine curve, something that we see from many data sets around the place at the moment. When you start to apply a whole nother level of granularity in terms of the data that it sits underneath it, you can see very different things. Now, this is quite noisy and difficult to interpret, but it gives you an idea of the types of features that can be extracted from electrical data. And when you combine that with machine learning algorithms that sit behind it, you can convert that into something else. Fingerprint, an identity, something that is unique to a device, or at least classes of devices. And once you start to understand that, then you can start to understand the behaviour of those devices, and you can start to understand ultimately the behaviour of those devices within individual buildings. And that starts to become a very powerful piece of information. That machine learning capability that reveals this information has many, many applications. And in the time that I've got, I'll go through a few of those examples. But what it also does is allow us to sit back and look at efficiency a bit differently. At the moment, energy efficiency is defined in a very particular way. I think what we can start to do is think about energy efficiency more holistically. And so at the moment, the industry generally gets typified with this notion of energy efficiency, turning things off. And it's almost punitive in nature. It's almost like you're frowned upon if you left the lights on last night, or if you used an air conditioner when you shouldn't have, punished if you like. But the reality is that as we can start to see individual devices and understand their behaviour, we can start to think in a more sophisticated way about what we mean by efficiency. And the World Energy Council had a bit of a crack at what devices themselves actually mean in terms of their overall contribution to inefficiency. And we heard the Minister talk a little bit about some of this. To put that in another way, the opportunity is equal to the total consumption by Japan in 1 year. So this is one of the largest economies in the world based on the fact that we have inefficient machines around the place. This is not turning things on and off. And so let's think about that in a couple of very real examples. This is my dad's beer fridge. It's probably almost as old as I am. It's a beautiful piece of old kit, and there's definitely some nostalgia associated with it. Is it efficient? No. Does it keep his beer cold? Yes. Is he going to do anything about it? No. At the moment, some of the devices that we just talked about, I could use to give my dad some data on his beer fridge. I could show him how many kilowatts it had consumed today. I could show him how many kilowatts it consumed last week. I could show him this week versus last year's week equivalent. Do you think he's going to change? Do you think he's going to do anything with that? He doesn't care. But with machine learning capabilities and the prevalence of devices that now extract information on individual devices, we can start using cloud-based platforms to actually understand this device versus others. We can start to present business cases to people in order to understand what it would mean for them to change this fridge out for a more efficient one and still keep your beer cold. You can also start to look at it in other ways as well. So this is a map of Australia's climatic zones. And so how do you think an air conditioner is going to perform in Hobart versus in Darwin? What we can start to do is we can again use machine learning algorithms, and this is current day capability, in order to understand the right tool for the right job, and not just simply rely on star ratings in order to understand or choose what it is that you do. So consumers can be given a lot more choice in terms of what it is that's right for them. This is another look at some data, because when we talk about machines, it's not just about bad old machines or changing them out for newer ones, but in fact running your existing ones better. So this scatter plot represents patterns of use or signatures of a stack of different devices. Let me strip that down to just one device, a vacuum cleaner. Machine learning algorithms have identified that is the signature of this particular device when it's operating in these patterns. There's some 450 different features that we're looking at to do this. We're just replicating 2 of them here. And what we can see is that that's a healthy representation of this machine. But what machine learning has also been able to do is look at another pattern that's emerged. Now, this pattern is not a healthy state for this machine. This pattern is when it's blocked and not operating efficiently. Now, what we can do is we can use this difference to actually communicate to end users what it is that's going wrong with their machine. They can take some remedial action, and all of a sudden, a machine that's not working well, may well be in risk of a breakdown, can be made efficient again. And this has lots of application. It has lots of application, not just obviously in households with beer fridges, but in industry and commerce across the board. Whether it's blocked filters, worn bearings, rotor bars, or a range of different things, these all have unique signatures of faults related to them that represent inefficiencies in those machines that are making them consume more energy, but also making them operationally inefficient because you have to service them more often or you're servicing them at the wrong time. So our concept of efficiency is not just about use less, it's about use wisely and understand energy enlightenment. Another example, and I'll finish with just 2, is around arcing. Now, this moves out of the box a little bit in terms of efficiency, but what we've clearly got to be able to do is provide a range of different benefits to end users to keep them engaged with what it is that they're doing. With high-frequency data sampling and machine learning capabilities, you can identify arcs. You can identify arcs within switchboards, you can identify arcs within individual devices. Now, clearly, if you're able to prevent those things or see them early enough before they create electrical fires, you're going to have massive ramifications both in terms of the insurance industry, but clearly in terms of safety as well. And then the last example that I want to use is the one that I call is Nana OK. So if you think about the capability to see devices and to recognise patterns, we can see the kettle, we can see the fridge, and we can see the toaster oven and a range of other things. What you can then start to do over time using machine learning algorithms is see the patterns of how they're used during the normal course of a day. And so Nana may be living at home in an assisted aged care facility, and it would be very, very easy to construct an alert based around when Nana switches the kettle on, for example, as a creature of habit. And so we can start to use these machine learning capabilities to provide a whole suite of benefits that not only are about just energy efficiency, but about human activity. And all of a sudden, my Nana, I can get an alert on my phone if she hasn't turned the kettle on by 7:30 in order to give her a call because maybe she's not been able to get out of bed this morning or fell over or perhaps even something worse. So the opportunities here in terms of what we're able to do are truly very, very significant. At Ecocentric, we're going to keep working on machine learning applications in terms of how we can benefit both people and planet. Thank you very much.